For 5 and 6, get ready to do some synthetic division. To find the upper and lower bounds, we first have to find the possible rational roots. So to do that, let's use the rational root theorem. We need to take a look at the factors of 24 and 1. So the factors of 24, we could have positive or negative, remember, 1, 2, 3, 4, 6, 8, 12, and 24. And obviously the factors of 1 are simply positive or negative 1. So if we divide all of these factors, so remember these are our p-values, by our only q, well, we get the exact same list here. And so we could have for our zeros positive or negative 1, positive or negative 2, 3, 4, 6, 8, 12, and 24. That's a lot of roots to test. So to figure out our upper and lower bounds, remember we need to use synthetic division. So let's just pick an easy number like 1, and let's see what happens when we do synthetic division into our polynomial. So our coefficients are 1, 2, negative 11, negative 24, negative 14, and 24. And if we do synthetic division, we should get this. So 1 times 1 is 1, 3, 3, negative 8, negative 8, negative 22, negative 22, 2. And so this tells us that 1 is not a root, and so we can cross positive 1 off of our list, but that's not what we're asked to do here. We're asked to look at the sign changes here. So we go from a positive to a positive, no sign change, positive to a negative, that is a sign change. Then we stay negative, that's no sign change. And then we go back to a positive. So we have 2 sign changes here, but they're not happening every other one, and they're not all positives. That tells us that we do not have an upper or lower bounds. Let's see what happens when we test out a number like 4. So if we test out 4, we use the same coefficients. We're going to get 1 here, 4 here, 6, 24, 13, 52, 38, 152, and 176. Whew, that's a lot of multiplication and addition. So we see that our remainder is 176, which means that 4 also is not a root. But more importantly, we see that we are positive on all of these numbers. The upper bound theorem states that if we get all positive results from our synthetic division, then we have found an upper bound. That means that our upper bound is equal to 4. So no zero or no root from our huge list over here greater than 4 can be one of our roots for our polynomial function. To find our lower bound, remember we're looking for these signs to be alternating. So negative to positive, or positive to negative, etc. And so let's see what happens if we test out the number negative 6. So let's do our synthetic division one more time. Get negative 6 here, negative 4 here, positive 24, positive 13, negative 78, negative 92, positive 552, I did use my calculator there, and 576. So again, a lot of multiplication and addition. We see that our remainder is not 0, so that means negative 6 is not a root. However, we're going from positive to negative to positive to negative to positive, which means we have a sign change every time we go to a new term in our result. That is what the lower bound theorem states for a lower bound. So our lower bound would be equal to -6, meaning that no zero less than -6, so -8, -12, -24, could be a root. And so we have narrowed our roots down in between 4 and -6, so that we don't have to do synthetic division all of the many times we have for our roots listed here if we were asked to solve